Good afternoon. Hey, come on, wake up. Good afternoon. I've got to rise the crowd up. Everybody's like, we've had too many cookies. My name's Lee David Aiken, and I'm a Windows Azure technical specialist. What does that mean? Let me give you a little bit of history. I started working on Windows Azure, or Red Dog as it was called in the olden days, back in January of 2008. So I'm coming up to 4 years on this. 4 years? Yes. Back then I was an evangelist, and I built the first set of training kits, and I kind of waved my hands a lot and things like that. I since then went and joined our sales group, and I actually now sit in the sales org, which is kind of weird. And it's like, we've got a sales guy up on stage, what's he going to do? I may be the only sales guy who lives inside a Visual Studio, and most of my job is helping customers build applications on the Windows Azure platform. Whether it's for scale or high availability, those are the types of things that we help them with. So in the next kind of 54 minutes, I'm going to walk through some of the big things that Windows Azure helps you with. So I'm not going to talk about, making asynchronous web calls and compressing content and all of the tricks that you can do on a single server. I'm going to assume you already know how to do those things. What I am going to do is show you some of the things that the platform can help with. And there's five big buckets I'm going to walk through. But first, I kind of want to think a little bit about scalable applications. What does it mean? An application is said to be scalable when we can add more hardware to it, and it will have more capability, more capacity, more throughput, handle more users. So my question always is, if the number of users or tasks increases, can our application handle that? That's the question we're trying to answer when we're working with these customers. So with that in mind, let's start off and talk about scale out. Everyone gets really excited about, you can deploy to the cloud and then you can scale out. There's elasticity and you can scale back down, and it's fantastic. There are some things that you have to do to your app to make that work. If you take your monolithic single server, one box kind of app and throw it up into Windows Azure and then tell it you need 5,000 of those, it's probably going to barf on you, right? Because there's a few things that you've got to do to make an app scalable. So let's look at a real simple scenario. We've got a web server. Let's say, for argument's sake, the capacity is 1,000 requests per second. I'm making these numbers up because I can do math on round numbers. If we wanted to handle 1,500 users, we all know how to do this, right? We go and add another web server. Hey, all of a sudden we can now do 2,000 users. But with that new server comes a lot of pain. First of all, we've got to go and probably wire up some sort of web form technology to push the content out to all the places. We've then got to go and put a load balancer in front of everything and configure that and put the networking together. And then we've got an issue of things like session state being on the machine. We have to go and get session state out of the machine. And that's just to really make Hello World work in an elastic environment. So there's some things you've got to do, and there's some things that we will do for you. So what I want to do is just show you how you can scale out with Windows Azure. I'm going to show you the things we do, which, to be honest, is underwhelming. I'm going to change a number in a dialog box, and we're all going to go, was that it? And then I'm going to talk about some of the other things that you have to do. So if we switch across to the demo machine, and I'm going to go into the Windows Azure portal. So I'm going to log in, I'm going to show you my password and everything like that. No, not really. Hopefully the portal will load, now that I've tempted. I was actually going to joke, if any demo went wrong, I was going to say that Steve Marks was backstage messing on, but he's actually sitting there and completely blown that plan away. So I'm into the management portal now. I'm going to go into my hosted service, and I'm going to show you the app scaling up. I have a few apps deployed. I'm not going to talk about all of them, but here's my thing. Here it's called Grainy Mix. What a name. And currently it's running exactly one instance. So in order for me to get to 5 instances maybe, I need to do some work here. Remember, we're talking about state, we're talking about load balancers, we're talking about VLANs, firewall rules, all sorts of really fun things like that. So I'm going to click on the deployment, I'm going to click on configure, I'm going to edit my live configuration, I'm going to scroll down, and I'm going to change this to from 1 through to 5. That's my typing skills over with for today. Click on OK, and that is it. That's all I have to do. Now, this demo is kind of a little bit underwhelming. It's like, dude, you changed the dialog box. But what we're doing in the background now is quite profound. We are finding another 4 slots within our data center where we can put you. We're doing it across a different fault domain so that if we have an outage, we don't take all of you down. Once we find those 4 things, we're going to provision an OS on there, we're going to put your app on there, we're going to configure that. We're then going to put you on the same VLAN as the rest of your application and update the load balancer to start putting traffic into there. We're going to set up some monitoring so we can detect whether your thing's running. And all I did was I click, 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 changed the number from 1 to 5 and clicked on OK. Now, I've just described what we do for you, and it's very easy. Now, here's what you have to do to make this app just work seamlessly. So first of all, let me show you the app. The app is outstanding. It's a HTML5 rich visual experience. Those that know me are now holding their breath at the tremendous graphical skills I possess. And it's a photo sharing site. And you'll see most of the photos have been uploaded by an automated test. So part of what I wanted to do was show you the difference in behavior as the app grows and how many users we put it against it. So that's that bit. So I can click on add photo, I can upload a photo, and everything's fine and dandy. Right now this is running on 1 instance. If I want to handle the thousands and millions of people watching this online who are now trying to upload the most wackiest photo they can come across, I better go and do something about that. 4 more instances are coming online even as we speak. But what did I do to my app? Well, the first thing is I need to take that session state and put it somewhere. I can't use the in-memory session state because that's not going to be shared between the servers. So we've got some choices. We can put session state into SQL Azure. There's a provider for that. We can go and put it into table or blob storage. But we also have a cache service. And what I've done is I've configured the cache service as my session state. Now, this was incredibly difficult, right? Because what I had to do was I had to click on some more buttons. I didn't actually write any code for this at all, right? So I go into App Fabric, I click on cache, and it's going to load up my things. I've got a subscription here for grainy cache, surprisingly. And then what we do is once you've created that, to get all the configuration you need, you just click on the View Client Configuration. And what that's going to do is just give me all of the cut and paste things that I have to go and take out of here and paste into my web.config. And there's even some comments in the XML that it wants you to copy to explain where to put it. So I kind of cut and paste job, put this into here, and here's my session state that I've added in. There's some other stuff up the top with keys and stuff. You don't need to see that. And that's all I did in my app. So I've pushed the session state out, put it into cache. It's going to be pretty responsive. Great. My data was already in blob storage, so when you upload a video, that's a different demo. When you upload a photograph, it gets stored in blob storage, and we'll talk a little bit more about that in a moment. So that's what I have to do. It's not just about, hey, we'll put it on Windows Azure and it'll all magically scale up. And part of the reason for this is we never build scale out applications on premises. We always build the web farm, and then we have the database. And what's great, you've heard about federations today and other database technologies. On premises, without fail, how we get a big database is by spending an incredibly large amount of money to build out the 64 core, 0.5 terabyte of RAM, SSD drives. We get some real smart people to do file groups and everything like that. Not anymore. In Windows Azure, I don't want you to create 1 database. I want you to create 100 databases and use federations. So think about scaling out everything. And we switch back to the slides. It's powerful magic. So we're able to build this out for you with the load balancer, provision the servers and everything with a few mouse clicks. But you've got to build an app that can handle that. And that's key. That's key to success on the Windows Azure platform. So that's kind of the first rule. Let's have a look at some of the kind of differences. So I was, didn't have anything better to do at the weekend. Thought, hey, I wonder if we load test this, what would it look like if we had one instance versus 5 instances? So here's one instance. And I want to point a few things out to you. First of all, the graph on the left is how much load we're putting against it. And the red kind of dotted line is showing the number of users increasing. On the right is the page response time, and you can see it's all over the place. And if you actually have really good eyes, you'll drill into that. There's about 300 seconds is the longest response time on that, right? When we did it with 5 instances, we'd run exactly the same load test. You see on the left-hand side, the number of users are going up, but the number of failures and everything isn't doing anything. And also, the response times are a little bit better. A little bit better? Well, first of all, when we had one instance, most of the tests failed. A large chunk of the tests actually failed because we couldn't get a response from that one instance. And this load test is uploading images. Okay. The other thing is the kind of response time overall on that is much lower. So even though the graph looks like it's in the same order of magnitude, it's not. It's way out. For those that couldn't see the graph too well, for a load test of about 1,000 users, the maximum load at any one time was 600. And you can see with one instance, we were able to execute 1.69 tests per second. When we had 5 instances, we had 13.9. Now, this should not be a surprise to anyone. We put more resources on it. We handled a bigger load. It should not be surprising. But we were able to do that because we pushed the cache back out, and we've done some other tricks as we'll talk about. So the next thing, if we think about the application, when you add a photograph, you could add any size photograph. And we have to do some work to resize it. And I think almost every demo today that you've seen involved some sort of image resizing and all that kind of thing. I wrote the first one of those on the plane to Europe after the first PDC, and it's still the same code, and actually still fix the same bug in it over and over again. However, and it's a capital case on the table name, just if you're wondering. So what we want to do is, instead of having the web tier get the photograph, resize it and store a thumbnail, and resize it and store a different size thumbnail, what we want to do is just store the original image and then hand off that task to some background. Now, this is a very simple model, but it could be used for anything. Let's say you've got a new user registering for your site, and part of your registration process is you send an email to the user clicks on the link, does the verification. You all know the kind of thing. Rather than have the web tier have to kind of go into the database, set up all of the kind of reply stuff, generate an email, send the email out, you can use this same trick and decouple the kind of the UI from the background processing that needs to happen. So, animated diagram. We've got our web roll up there, we've got blob storage, and there's my image. What happens is it gets uploaded there, and the web roll generates the two things like that. Highly inefficient, because every time someone uploads a picture, I've got to do all these calculations and all these writes. So instead of that, what we've done is we've added in a worker role. Now, a worker role is exactly the same as a web role, but it doesn't run IIS. Everything else is the same. So I can put some code on here, and perhaps it's a Windows service, and I can adapt that and make it run in a worker role. So quite often you've got code already that works in this kind of background fashion. And then what we're doing is we've put a queue in the middle of that. So now what's going to happen is I upload my image, and we have to store that somewhere, so let's put it into blob storage. It needs to be there anyway. But then instead of doing all the resize stuff, we want to return back to the user and go, thanks for your photo. We're going to stick a message in a queue. That's going to go across to the worker. The worker reads that message in, pulls the image in, does the resize, stores the images back down into blob storage, and we're all done. And this can be used to decouple any task that you don't have to do immediately. And the bigger the scale, the more things you're not going to do immediately. In fact, it's almost a design point of like, what's the least amount of work I can get away with doing? Or rather, can I do all of this later? And the more you can do later, the better. So why worker exists, why we have a queue construct, is to build this exact pattern. And you'll see most of the sample applications that we put out there, but also most of the applications that we're building with customers use these patterns to enable the scale out. If you don't have to do it now, put it in a queue and have something do it later. It allows you to scale out individually as well. So you could say, right, hey, to handle all of these images that are being uploaded right now, just in case I show the page again, and good luck with that. We could scale that out, and we could have 100 web roles, web instances running. We might have a queue and one worker, because that's all we need. And it can sit with 1,000 messages in the queue and crank through them whenever it likes. Or we might be like, hey, we want to turn that image around real quick. We could put lots of workers on and increase the number of workers based upon how many messages we might have in the queue. So there's some great extensibility points and some great scalability points there. I think we had a question in the audience there. Someone kind of went.
Yeah, I did. I do have
you, sir.
One of the difficulties that you have when you do anything asynchronously is exception handling. So I'm curious, if you're putting off that processing for later, how do you deal with exceptions or letting the user know that there's been an exception?
Great question. Let's switch back to the demo machine and remind me before I flip back to show you what I've done in this sample. Now, I must warn you, I haven't written production code there. And just to be clear, the question is, how do we do exception handling? Just for the benefit of those online who heard me say, yes, let's answer that question, but didn't hear the question on there. So let's take a look at that real quick before I forget. So inside my code, I actually have a worker role. And in my worker role, I have some really, I'm fully object-oriented. I'm using Unity and all sorts of things like that. I'm not, by the way. I'm not even using any clever object serialization. Like the most straightforward thing I could think of doing was actually putting the image name along with the image metadata in a kind of delimited string and putting that in as a message. So this is the quickest code I could write at 1 a.m. in the morning. But what I do is every time you read a message from a queue, we increment the DQ count. Now, just to explain this a little bit, when I read a message from a queue, we don't get rid of the message, we hide it. Now, I might be doing some work, I might be resizing it, and then I might kind of, the hardware I'm running on might fail, or a problem might happen, and I don't get that piece of work finished. What's going to happen is eventually that message will time out. You can control how long that is, and the message will reappear back on the queue. And then my worker can do it again. Now, maybe there's a problem with the message. Maybe it's pointing to a file that's being deleted from blob storage or didn't make it there or something. So I'm going to read it in, I'm going to try something, I'm going to throw an exception, the message will appear back there. The DQ count will have been incremented. So what I've done is I've got to check in there and say, hey, you know what? If the DQ count is greater than 5, and in my demo app, delete the message. If I was building this to be more production, I would put that message into a dead letter queue, which it's not a special queue, it's a queue I will call dead letter. And I'll have a part of my ops process to monitor the messages in that queue and take some action based on them. So, the principles are the same. I don't think you do anything different on premises. You maybe have some better tooling to handle it, but the concept's the same. Does that answer your question? Yeah, excellent, thank you. Why was I in this demo? Yes, to show you the queue. So this is doing it backwards, but here I've got a worker role. And in the worker role's main method, I have a run method, and I've got a while true, because that's the most awesome piece of code. And what I do is I go and get a message from a queue. And I set the time span to time out after 2 minutes. So after 2 minutes, this message will reappear back on the queue. I then figure out what was in the message, and then I go and do my resizing, and then when I'm done, I delete the message. And that's all my thing does. And it just sits and loops around. I put a little bit of complicated logic in to back off so that it's not sitting pulling the queue constantly. You can come up with a little bit more elaborate than I have, but it's great to show the point. Now on the client side of that, in my controller, and I put everything in the same controller because again, this code will be deleted. I actually have a little switch in my app so I can tell it to use the worker or do it all, and that way I can mess around with it and do different tests without redeploying. So here basically I'm saying, look, am I using the worker? If I am, I'm going to create a message in a queue, and if I go to this piece of code here, basically I go and get I've got to go into the queue repository. See, that was a little bit kind of cool. So I put message, I go and create a queue client account. I didn't say that right. The part of the storage library has a wrapper for manipulating the queue. I go and get a reference to my queue, which I've imaginatively called images. I go and then create my message, which again, I was like, I could have serialized it as JSON or XML or something, but that might have needed looking up some code, so I just wrote that. And then I add the message to the queue. How the message is structured is entirely up to you. We just like a string, thank you very much. And that's it. Deploy my worker, deploy my web, all are part of the same package. And I can scale them all out individually. Super, I answered your question. Great, let's switch back to the slides. So it's really easy to go and add a worker and to decouple this process. In fact, a lot of the things you do in your web applications, your websites, can easily be placed into this model. Things like sending user emails, updating content, all those types of things can fit into this model really, really well. So I thought, I wonder what would happen if we run the same load test on here. And I kind of look at it and I was like, oh, it didn't change very much. So the difference between 5 instances and 5 instances with a worker is, a little bit, there is some difference there. And then I did the slide and I was looking at the numbers going, I need an explanation for why it didn't make a huge amount of difference. So I looked back at the tests, and actually the test rig is sitting idle because the thing just responded. There was no other, I needed to put more load on it to kind of push it out or break it anymore. That's as fast as the test rig could go. It's not as fast as the app could go. So I was kind of like, oh, now I need a bigger test rig. Great news is my test rig is actually in Windows Azure. We have a bunch of blog posts telling you how to do that. And I have 30 agents running right now that I can hit my site with and try and take it down with. So that's a great thing to think about as well. But part of the reason why I wanted to show you some of this data is one of the biggest challenges in building a highly scalable app is knowing, does it scale? How do you figure out, can I handle my 20 million Facebook users that the marketing teams told me they're going to get? We deal with a lot of kind of marketing, digital media companies where, while they're building it, they're going to get a few thousand users. And then come lunchtime, there's going to be a TV campaign in the middle of, the X Factor or something, and you're going to get like a couple of million people hit it within the space of an hour or two. How do you test a few million people in an hour? Like, it's almost like I need to build another huge thing alongside it to go and test the darn thing in the first place. How do you test 1 million concurrent users? Kind of hard, really. But one of the things I wanted to show you is you don't have to go as far as that. If you can test a couple of instances and then test that deployed several times, you can start to get an appreciation for how it scales up. So I did 1 instance and I did 5 instances, and I saw how the thing improved on that. I know that 5 instances can handle 1,000 concurrent users over 10 minutes very easily. That's how long the test took to run there. What I end up doing is building what I call a scale unit. And a scale unit is very important. It is how many resources do I use together to handle a specific load. So this could be how many web servers do I need, how many queues do I need, how many worker roles do I need, how many storage accounts do I need, how many SQL Azure databases do I need. And maybe my load is like, hey, for every 5 web servers, I need 2 storage accounts and 8 SQL Azure databases. That becomes my scale unit. And then I know as I increase the users, I increase my app by an order of magnitude on that whole thing. So if I have to double it, I double the web, I double the SQL, and I double the table storage as well. So you have to start thinking about these patterns. And there's an order of magnitude different. I have never met a customer that got upset when I said, oh, you need 100 web servers to handle this load. But as soon as I say, hey, and you need 70 databases, they're like, what do you mean 70 databases? Does this cloud thing not scale? I'm like, whoa, time out, time out. Like, you get the web thing scales out. The database does the same, right? There's only so much physics that can go on with a single machine before doing it 2 machines. It kind of works. I could do this talk faster if there was 2 of me, and we said, different parts of the talk simultaneously. Anyway. So that's one thing. The next thing, so scaling out everything, decoupling tasks, great solution. What about cache? So a lot of content that we deliver is the same content over and over again. I'm talking about the style sheets. I'm talking about the jQuery stuff. I'm talking about your static images and all that kind of fun stuff. I am not talking about my personalized homepage that only I get. I might not want to cache that. Why? Because only I'm going to use it. So it's very important to kind of get your head around the use case for a cache there. Windows Azure has a caching service. So here's the scenario. I'm in Australia. I'm kind of in the sea off Australia, but I'm down that part of the world. And my data center is in the north of the US. Saying the north of the US reminds me of Boston, and I have to say hi to the Boston user group. And I was there a couple of years ago, and I will get out to them again. So that's why my app is. So if I want to view one of those images, my image has got to kind of go all the way down to the bottom. But what we have is, as well as the data centers, we also have a content delivery network, or a CDN. And we can actually take content from blob storage or compute down to one of these endpoints and cache it at the endpoint. So in the case of our image, if our image is located there in blob storage, what can happen is I can go on, when I make the request from Australia, I will get routed to the CDN endpoint in Australia. It'll go, I don't have that image. It'll go back to blob storage in the US, pull that image down, cache that there, and serve it up there. The great thing is the next person that comes along, the image is already there, I can just give it out. So this is great for static content that doesn't change. For dynamic content that is constantly changing, there's different ways you can cache, and putting it into a CDN network perhaps isn't the best idea for that. So serving content from the edge, we have 24 global locations with an SLA around that. We can now deal content out of web applications. So the first kind of release, we could do blob storage. Now we can actually deliver content from your web projects and push it through the CDN. So just to recap, that's blob storage. It's a public container. It needs to be a public container. What that means is you don't need a storage key to access. It's just a public URL. Anybody can hit it. And if my user makes a request, then hitting blob storage, it's potentially miles and miles away. It's going to be subject to the network conditions between me and the data center. Enter the CDN. So what happens is I request this object. I get routed. DNS routes me to the closest point of presence. From that, it then looks and goes, oh, have you got that object? No, you haven't. Let's go back to the origin or the blob store, pull down that image, cache it locally, deliver it back to the client. How long it gets cached, you can configure, and it'll send back to the client. Next time someone in that region accesses that piece of content, assuming that the cache hasn't expired, we'll hit the closest point of presence. Hey, the object's already there. That's the only hop we have to do. So there's fewer hops. Your app will behave better. Another thing we've done is our web server now isn't handling the request for that. Ooh. So you're kind of getting web serving content for free, right? You don't have to build a web server to deliver this out. And you get your blob storage as one point, and the other 24 points give you, this content distributed around the world for that. You can be really slippery and tricky with this. If you've got a page, that makes it an AJAX call to pull back a menu, and the menu is normally delivered in JSON format. Why don't you store a JSON format file in the CDN and pull it from the CDN and then render it? Ooh. Then when you update your database, you can update the database and just use a worker role to write the new JSON content down into the blob storage. And again, you can not only offload content from your web servers, you can also speed up the page rendering and their interaction at the client side as well. So some great tricks you can do with a CDN. Let's see how we configure that. If we flip across to the demo machine, and what I'm going to do is flip into my CDN. And there's two things I want to show you. This is still, oh, that's worrying, it's still updating. But it's still updating. We're going to, hey, ta-da. Thank you. I don't know why I looked up there, the data center's that way. I'm going to click on CDN. And what I've done is I've created a blob storage account, and then I've enabled the CDN for it. And there's some trickery you've got to do for this. And again, it's a couple of mouse clicks. But what I've got here is I've got my Grainy Mix 2. And I have, sorry, no, where am I? I am Grainy Store 1, which is my blob storage. And here I actually have a CDN endpoint. So I get a different DNS name. It's az89802.vo.msecd. It just rolls off the tongue, right? But I get a different DNS name. Now what I want is, that looks lousy. What I want is to be image.davidaiken.com, which is my domain name. So what I've done is I've created a custom domain, and then there's a little process where we ask you to set up a new CNAME. We ping it to make sure you own it, and then we can kind of confirm that. Once you've set that up, it takes about an hour to kind of do it, so that's why I'm not doing it as a live demo, because it's kind of uncomfortable standing around for an hour waiting for it. Once I've done that, it's simply changing my app to render that URL rather than a blob storage URL. Simple as that. For compute, it's a little bit different. So here's my web gallery, and it's a web role. It's just a web app. It's MVC. It's standard, file new MVC app, no cleverness. What I've done is I've created a CDN folder. And in there, just as an example, I've put my CSS. And then within the layout, I've actually said, look, I want to go and render this from cdn.davidaiken.com. See, I'm the only kind of Microsoft guy with actually a CDN for my blog. Mark's has one. Yeah, you have one, sorry. Steve. So that's my URL to pull down that style sheet. Back on the management portal, my app is called Grainy Mix 2, so the one that uses the CDN and the worker role is called Grainy Mix 2. What I've done is I've created a CDN endpoint for the app. So this is different from the one that's blob storage. So I get a different URL. So I create another CNAME, map that across, and that's how I get the cdn.davidaiken.com. Again, there is no code to kind of go and put together for this. I have to change some URLs, I have to go and configure some DNS, and now my content from my compute will get cached onto the CDN in exactly the same way. I can put my images down there, my static content, my whatever. Fantastic. So let's flip back to the slides. So, caching static content, really important. There's some great tricks that you can do to push down not only static content in terms of traditional file size things, but also, that page that renders, and there's a couple of, AJAX requests that go back, and the content's fairly static. You kind of go, what if I just read the JSON response from blob storage? Wouldn't that be kind of cool? And you wouldn't believe the scalability you can get from that. One more thing, just on the scale out. You've got to run your numbers, and there's actually a question on Twitter which is asking about, do I have rough numbers on the expected performance in a SQL Azure instance? And the answer, quite frankly, is no. Right now it is too dynamic to kind of have a ballpark figure. We are working towards making it more deterministic. However, for Azure table storage and blob storage, we actually publish scalability targets. And you have to look at the scalability targets. And if you're in your head, you're going, look, I need to be able to handle 20,000 requests per second. You need to go and take that number and look at our scalability targets and then go, oh, it turns out I now need 4 storage accounts to do it. Now, everybody kind of gets 4 storage accounts. Again, the web tier, you get to scale out the web tier. And then when it comes to storage, you expect just some magic thing to happen, right? We don't build you 64 core machines in the data center. We just give you 6,400 little ones to go and do it. So, keep that in mind. Scaling across data centers. So we put the content there, but we also have 6 data centers that we can put Windows Azure into right now. We've got 2 in the US, 2 in Europe, and 2 in Asia. If my app is deployed into the north central US location and my user's still in Australia, and just before I came out, I looked at this slide and there's actually a computer on it, but the computer is about 2.5 feet to the right of Australia off the screen, and I had to move it to kind of do something. So that's why the computer's not there. So here's how Traffic Manager works. So what is Traffic Manager? I can deploy the same app into every single data center. Ooh. That's cool. But then, how do I get the user to the right data center? Enter Traffic Manager. So here's how this works. Here's my user on 1.2.3.4, and I've deployed my app to 3 regions. So I've deployed into the US, into Europe, and into Asia. And remember, my user is in Australia. So I'm guessing Australia might be the best place to send them. I'm not sure yet. Enter Traffic Manager. So what happens is we go make a request for foo.net. What's great about this is, again, I'm doing some CNAME indirection. Foo.net will actually point to foo.trafficmanager. Whatever the suffix is. So Traffic Manager takes a look at the request coming in, and then it has a look at the policy for this particular setup. And there's different policies it can have. I can do round robin, so I could send all the first request to the top one and just kind of go and loop through them. I could also do it based on failover. Oh, what does failover mean? Well, we'll send them all to the US until the US is down. Well, how do we know it's down? Well, part of setting up Traffic Manager is you have to configure a ping. And Traffic Manager will ping your app on a particular URL that you define. And if it gets a 200 response, the world is good. If you give it anything else back, the world is not so good, and Traffic Manager thinks you're not running. At which point, it'll start directing users to the next one down on the list. Regardless of which policy you use, if your site becomes unresponsive, we'll redirect you elsewhere. The third policy is based on performance. So we collect a whole bunch of network statistics and we do active monitoring of what's happening around the place. And based upon that, we figure out where to send the user. And this might change over time. As there's transient network conditions on the internet, wow, that's never happened before, we'll route people to potentially different places. Now, the way this works is hocus pocus DNS stuff. So, when I make the request, it works out which DNS name to give me back and gives me one back with a time to live that you can configure, but typically 5 minutes. After 5 minutes, I go and resolve that DNS thing again. I might get a different place to go to. The kind of thing you've got to face is like, hang on a minute, if I get US and then I start hitting the US and the US goes down, I'm going to be down until my DNS goes and looks up again. Correct. Also, by the time you figure out DNS was down, got to a machine, logged in, tried to figure out what was going on, chances are the DNS cache has expired and the user's happy because they're now hitting the next one on the list. Okay, so you've got to play with that. Anyway, back to this. We get a DNS response. It's going to send us to Asia on this particular account, and that's how that will work. So how do we set this up? So I've got a different app that I use to show for this. This app is the world's best or funniest, I'm not sure, URL shortener. Everybody who tries this out always complains that it gives them a longer URL. And I'm like, it's a demo. It doesn't matter. Anyway, so it's called Humble Me. It's currently deployed into 2 data center locations. And there's 2 things I want to show you. One is you can put content down to the compute to the local user and scale that way. You can also get the benefit of failover. So I'm going to cause a failure in a moment, but let me set this up first. So when I hit www.humble.me, and it took longer to think of the domain name than it did to build the app, let me tell you. If I go to the northamerica.cloudapp.net, this is orange. If I go to the European one, it is gray. They're just two colors I know how to do in CSS. Work with me on the design thing. So what's going to happen is when we fail, the screen will go gray. Now, at this point, what's really helpful is if we can, well, first of all, let me show you the virtual network setup for this. So we'll go into, not interconnect, into Traffic Manager, and I actually have a policy set up for this. It'll take a second to load. And it's funny, we're transitioning Traffic Manager from a closed CTP, which was you had to apply for it, and I got an email saying that we were going to open that up. And what worried me is we're going to change the DNS name. And I'm like, no, not while I'm on stage, right? But it's the same, so we're good. So this is my thing, my Traffic Manager policy. If I click on Configure, you can see it here. I've chosen Performance. This is my DNS name, so I map my www.humble.me to this. And these are the two services that I have. I also have App Health. Sorry, this is the DNS name. And I have that App Health path. So let me go and view the App Health page on that. Now, again, massively amazing HTML. This is HTML5. Thank you. Come on, the only applause I get is when I literally have no HTML tags at all in this. But it returns a 200 response. Traffic Manager doesn't care, right? Now, what I do in this health page is I go and ping every dependency that I have. I go and make a call into SQL, and I return like the version number or something. So I make sure I can connect. I go and talk to all the other dependencies that I have. I clearly have millions on a URL shortener. And if everything returns good, I return 200. If it doesn't, I return 400. So what I thought would be cool is if we could just get an outage. So I'm just going to call the data center and see if we can just pull the plug from the North Central. All right. We can't do that. So I had to build a kind of short circuit in my app. So if I go to fill status, I can actually go and say, hey, look, let's go and fill for 15 minutes. And it sets a little flag. But then when I go back to the app health page, I get a 404. So now Traffic Manager is going to, every 30 seconds or so, is going to ping my site. After it gets a couple of bad responses, it's then going to fail over and send everybody to Europe. Now, the challenge we've got is we won't stand around while this is happening, right? Part of the reason for this, I've found, is IE caches the DNS entry longer than the machine does. And you can change this in a registry entry. And I can never remember what the registry entry is. And I only ever remember this when I'm at this point in the demo. So what we're going to do is nslookup www.hmbl.me. You can see I get na humbleme.cloud.net. Now, in about 5 minutes, we're going to come back to this. We're going to run the same command, and we'll get the Europe one. And that will be our evidence that it will fail over. IE, however, we'll try and go back to the North America one for 30 minutes, I think is the default. It's fantastic. Anyway, we've got a couple of questions on Twitter just while we're waiting for that. Does the Windows Azure CDN can automatically compress static content like CSS or JS files on that? You have to put the content in however you want it delivered. Thanks, Steve. Because I didn't know. Another question on okay, there's a question on Twitter about Hadoop. I do not know the answer. I'm not even going to bother with the question on that. I'm not a Hadoop expert yet. Cool. So Traffic Manager is filling. That's going to catch. Oh yes, yeah. IQ-config/flush DNS. Yeah, I do. You get going thing on there. You can tell this is a demo machine rather than a dev machine, right? IQ-config/flush DNS. I'm going to be in trouble off Jeffrey Snover now for not opening a PowerShell window and doing this. nslookup www. We still get North America. we'll give it a few more minutes to kind of whack out of that. Let's flip back to the slides, and we'll wrap up and take some questions, then we can flip back to this on here. So using Traffic Manager is real easy to go and deploy your application in multiple places. We take care of getting the traffic to you. However, you have some challenges, right? And I think we might actually have time to dig into this a little bit more than I thought. So can we flip back to the demo, please? Just to keep you on your toes, thank you. I use a SQL Azure database as the back end, surprisingly, because that's what a lot of people use as well. Now, if I go into the management portal, and actually if we just do a little refresh here, will it refresh 5, 4, 3, 2? I'm not saying that there's a status message coming up at the bottom that does that. Yeah, we might have to. I don't want compatibility view. There we are. And we'll just flip into Traffic Manager. It's funny, everybody online's there. Does the sound go off? We'll flip into back into this, not into Connect. So I do the same thing all the time. You can see, Traffic Manager thinks the North America's offline. Okay, so it's just a matter of seconds before. More seconds than I'm giving it for do that. Anyway, so I use a database. In fact, I actually use 6 databases as the back end. So every deployment of Humble Me has 6 SQL Azure databases at the back end. I built this app before we had federation, so I actually manually handled the connection strings, and there's 6 separate databases. Now I've got 6 databases in Europe, and I've got 6 databases in North America. And if I go and hit Europe and I create a new URL, and then I go and share that on Twitter, and someone hits the North American data center, oh, the data's not there. So I need a way of syncing the data between the 2 places. Enter the data sync service. So data sync is another service as part of Windows Azure, and what we can do is we can take data in 2 different SQL locations, and I say SQL locations. We can sync between 2 SQL Azure databases. We can sync between a SQL Azure database and a SQL Server database, which may be, in your existing data center. And it runs as a service. So again, there's no kind of setup other than click, click, click. I'm going to show you what I already have set up for my Humble Me application. In terms of the member databases, I have 2 servers connected there. You can just see in the top corner there. I'm mouse challenged today for some reason. I want to move up. I want to move up. I want to move up. Actually, click on the DOM thing. You can actually see I've got Humble Me URI 1 through 0. 0 through 5, I guess, is the right way to say that. What I do is I take the URL that gets shortened, I do a hash on it to figure out which one of the 6 databases I go in, and then I go and store that in there. And it's a deterministic hash that I use, so I can repeat it. But I had to set up 6 data sync groups to go between this. So that's my database, and thankfully there's no database credentials showing up because I really don't want to destroy this site. But if I go into a sync group, basically what I've got is the same database from each server. And I created a server in Europe and a server in US. And I told it, hey, go and take Humble Me 0, and go and sync them bi-directionally. In CTP, we're going to do it every 5 minutes. I pick which tables I want to sync between them, which columns I want to sync, click on OK, and we go and set that up and then keep syncing it every 5 minutes for you. Piece of cake. Again, I didn't make any application changes to do this. It's something that I think, and I strongly believe, is something that should be external to your application, because as soon as you have to start putting code into your app to handle multiple data centers, you start digging yourself a real deep hole, and V1 will get out the door, but V1.1 will just be some hideous nightmare. And I'd rather you didn't call me if that's what you did. Try the NS lookup again, I'm being told. Shall I flush the DNS? Yes. And then I'll do an NS lookup. Fantastic. really easy to set up. I built my application for one data center. God, I never thought I'd be standing on stage at Microsoft saying, I only built my application to work in one data center, and we turned it and ran it in two. It's like, wow. And I built this app on a plane to Boston for the Boston user group 2 years ago. So, how else can I get this power? It's mind-boggling sometimes. Anyway, let's flip back to the slides and we'll wrap up and take a couple of questions. There's a question on Twitter. Is it possible to run multiple worker roles on one compute instance? So this is a common question, and I want to take just a minute to answer this. A worker role really, and all of our design points for scalability are really around scaling out big stuff. So, hey, I need to handle 20 million users in between 5 p.m. and 7 p.m. Can you help us? Yes, we can. We're going to have lots of servers, and it's going to be exciting. And then there's the other thing is I want to run a worker, but I need to be able to do 97 different things. Because every 2 hours I need to run this job, and then every 5, and then it needs to, and whatever like that. And if you kind of look through the material, it's kind of like, hey, you would have 97 different worker roles. And then the question is, well, how do I get all the worker roles into one? And it's like, no, that's not the question. You're having one worker that's going to do multiple things. And one of the best things you can actually do is write them all completely multi-threaded, unaware, and then use the .NET 4 task library to go and run them all in parallel. And your worker code would just start up and just go and run all of the tasks and be done with it. I think multi-threaded programming is best left to somebody who isn't me, quite frankly. But I've time and time again in different apps, I've seen some incredible performance gains just by using the task library across a simple single-threaded thing. And it could be a loop. Remember when we read the message? I read one message. You can read 32 messages at a time. And you write a little for loop for each message in messages, do something. And then once it works and you've debugged it, you then change it into a parallel for loop, and it'll do all 32 at the same time. Well, it won't. It'll do some at the same time based upon what else is going on. The great thing is you don't have to figure that out. You just know it's going to go and it's going to run better. So that kind of answers the worker role question. Just to recap, so first of all, scale out and scale out everything. I have tremendous excitement when people come to me and go, hey, Dave, I've got 27 SQL Azure databases, and I wonder if you could, hey, cool, you get it. It's when you come to me and you're like, hey, I've got 90 web roles running extra large, and I've got a 1 gig SQL Azure database, and my site's not very responsive. So we added more web roles to the thing, and now we're up to 120, and it's even worse. So then I saw one of your talks, and that always kind of, and you said put retry logic in, and we did, and it made it even worse. So we took it out again. So don't, right? Scale out everything, whether it's queues, whether it's storage accounts, whether it's databases, whether it's things we already get like web roles. Use workers and queues, decouple that, get rid of that work from the web tier. Do it in the background, it's great. CDN is your friend. It is just the lowest. It's like we bill you a little bit more to get the object from one place to the other, right? And then you get charged some bandwidth. It's like you would get charged bandwidth if you were serving that out from a web role, but you don't even have to pay for the web role because it's on the CDN. You just got a picture of me going like this. Fantastic. For those I have no idea what online sees. Anyway. So use the CDN. Traffic manager, when you start to think, hey, you know what, I've got 20 million users, they're a global presence, how do I get the response times, how do I start pushing content and compute into those places? Traffic manager is going to be your best friend, along with the data sync service to kind of help you figure out how to keep all of those database kind of things in place. I have about time for one question, but other than that, thank you very much. You've been a great audience, and I hope I've woke you up a little bit. Thank you. Do we have one question? One question. There, you sir.
Yeah, he asked a question about debugging the response when you decouple. All right. If you want to give a user immediate response, like for example, in an application, somebody is placing an order, the ERP checks whether he's on credit lock. Let's say he exceeded his credit. You need to give him an immediate feedback saying, sorry, you cannot place this order. Putting it in a queue, how do you
So
How do you keep those two healthy?
So let me, just for the people online, so the question is, if I'm placing an online order and part of the process does some sort of credit check, and then I have to get back to the user going, sorry, you don't have enough money to do that. And I have to get back real quick. How can you do that with a queue mechanism? So I would challenge the assumption that you would have to respond quickly. And there's a number of reasons why I do that. First of all, almost always when you're doing some sort of credit check, you are going to a third-party dependency, which may or may not be there, may not be responsive. You may be going to a back-end system or something like that. Why do they need to know right there and then? We challenge that assumption. Could I place the order and then on the fringe case where they don't have enough credit rating, we send them an email, hey, we got your order, we're real sorry, we did a credit check, and like, scumbag, whatever. But why do we have to block on that synchronous call? And I would challenge every time someone comes to me with that is like, can you design that out? Is it acceptable to design that? Sometimes it's not, in which case using a queue probably isn't going to work for you. However, if you're then hitting that dependency and expecting a synchronous response, what happens when that dependency isn't there? That's a completely different talk, by the way. So you need to kind of figure out what that is. And the normal solution for that is to put the message on a queue and deal with it later. At which point you kind of like, oh, why don't we just do that as the default? So I can talk more about that. And you can reach out to me. My name with a dot in the middle @microsoft.com is how you reach me. Brilliant. Other than that, thank you very much. Thank you.